Hello, in this video we're going to be talking about pyruvate oxidation, so let's not waste any of your time. Let's get right to it. Now, when we're talking pyruvate oxidation, the main thing you want to think about is the fact that it's a conversion stage. It's a pretty short step. I mean, it is a step, but it's by far the shortest of the four or five. And really, it's taking the final product from glycolysis and converting it into the starting material for the Krebs cycle. So there's really just a couple of things that are going on here, but pretty important things that you want to recognize. First, as we showed the picture, it happens in that inner membrane of the mitochondria. And of course, you've got the two pyruvates. But what was really happening, and you can see it in the bottom left of that diagram on the far side, the blue arrow pointing into the light green box. It's the idea, you can see an NADH is made. Okay, but what's really the focal point is that carbon dioxide coming off of the molecule, converting it to that acetyl coenzyme A. It's basically an enzyme being added to make it an acetyl group, but that carbon dioxide being removed. You can see on the far right those two boxes, the pyruvate and the acetyl coenzyme A box. You can see that the conversion there, one of those C's on that middle branch and two of the O's are removed, the one from the end and then one of the ones in the middle. And that's the carbon dioxide that's being removed. And then of course then that CoA, that coenzyme A, is attached as well. So it's just converting it. Once we get to the Krebs cycle, you'll see that as the starting material for the Krebs cycle. The takeaway is that carbon dioxide molecule being released and the enzyme being added. Those are the two things that you want to think about when you think pyruvate oxidation. So here's our summary screen for our slide for pyruvate oxidation. Again, we've got our end products here, and we've got our purple boxes with all the information. Those are going to be, when it comes to tests and quizzes, those are going to be those boxes that you really want to pay attention to, that you're going to make sure that you get written down. But again, just like with glycolysis, you want to think twos. Okay, two end products, two acetyl-CoAs, that's the molecules that it's converted to, two NADHs and two carbon dioxides. And again, but if you look at the diagram, which is the bottom part above the purple on the left hand side, you only see one of these, and you just got to remember in your mind that there are two molecules that this is being done to. The slides and screens will show you one, but you got to remember that this is the other one. So if you're ever looking at something and you're looking at a diagram, you look at the end products, and it doesn't match up math-wise, number-wise, got to remember that there's two. So what you're looking at on the diagram will typically, well, not typically, will be half of what the end products, and you got to remember that there are two. But I'll always remind you of that. So that is our video on pyruvate oxidation. When we come back the next time, we'll be talking about the Krebs cycle. So we'll see you then.